Hello everyone. In this video we're going to be solving a very radical equation. We have the square root of 1 minus x plus 1 all over 2 minus x squared equals x times the square root of 1 minus x squared. Obviously this equation can be written in many forms, and this problem is from a book in Russian which can be translated as Selected Advanced Problems in Mathematics. I'm not really good at pronouncing it, but I'm going to give it a try. Izbranie zadachi povishennoy sложности po matematike. Anyways, I probably butchered the pronunciation, so forgive me if I did. Really good book with beautiful problems. Anyways, let's go ahead and see how we can solve this problem. And again, like I said earlier, we can write this equation in so many different ways. So let's start with this. Square root of 1 minus x plus 1. That is divided by 2. And then I'm going to put the x squared on the right hand side and then add the radical, another radical to it. Now we have something like this, and if you try to solve this equation normally, like usual methods, you'd probably try to put the radicals on one side and square, or maybe isolate them. Let's go ahead and multiply 2 on both sides first, and then maybe, and this we can call, I guess, the first method, square both sides. What would happen if I squared both sides? I would be dealing with lots of terms, but it's basically going to look like this. Square the first term, square the second term, and then add to it 2ab. As you know, that's a formula. And in this expression, we can kind of split up into a sum like this. Square the first term, square the second term, and then add the 2ab thing. This is going to be like 4x cubed. And then, of course, I need to add another 2 there. So it's going to be 8. 2 times 2 times 2. X cubed multiplied by the radical, square root of 1 minus x squared. Now, notice that nothing seems to be canceling out. I'm getting x cubed multiplied by a radical, which is really problematic. I'm getting an x to the fourth, another x to the fourth here. Well, actually, they cancel out, but still, we have a lot of issues. And you would still have radicals, which you had to eliminate somehow. But again, this is way too painful, and I don't even know if this is going to end at a good point, right? You can go ahead and give it a try and let me know how that goes. Maybe there's a solution to do it. Or you can try answering it on Wolfram Alpha and see if it's going to respond with a nice solution. I haven't tried it, so I'm going to leave that as an exercise for you. Great. So let's go ahead and take it from here. We multiply both sides by 2, and we got a radical. So we have now square root of 1 minus x plus 1 equals 2x squared plus 2 times x times the square root of 1 minus x squared. Now at this point, I'm going to do something pretty interesting. First of all, focus on what's inside the radical, 1 minus x squared. That kind of tells us that, hey, 1 minus x squared, if we're looking for real solutions, of course, needs to be greater than or equal to 0, which means x squared needs to be less than or equal to 1, which means x needs to be between -1 and +1. Of course, you could arrive at this by subtracting 1 and factoring it, or you could use the square roots and absolute value. Make sense? You get the same thing. Now, at this point, we're going to do a hocus pocus abracadabra super duper amazing substitution, which is x equals cosine of alpha. Now, a good question would be, could we use x equals sine alpha? Again, you can go ahead and test it out. If you replace x with cosine alpha everywhere, here's what happens. Square root of 1 minus cosine alpha plus 1 equals 2 cosine squared alpha plus 2 cosine alpha multiplied by the square root of 1 minus cosine squared alpha. Now, I need to make some restrictions here so that our answer is going to be nice, and actually things are going to work nicely. I want my alpha to be between 0 and pi. And that's going to be good enough because I'm also hitting the negative values of cosine, but at the same time, I'm making the sign positive, which is nice, right? On the first and second quadrant, in the first and second quadrant, sign is positive, right? And of course, this also implies, not that, but the inequality. Half of sine alpha, sine half of alpha is also going to be greater than or equal to 0, all right? Because if alpha is between 0 and pi, then half of that is going to be between 0 and pi over 2, which is the first quadrant. Awesome. Now let's go ahead and do a little bit of, putting things together. So I'm going to go ahead and subtract 1 here. There's a good reason behind that. You'll see in a little bit. This is 2 cosine alpha. And this is normally sine squared, and square root of sine squared is absolute value of sine. But we just noticed in the first and second quadrant, sine is positive. So this is directly going to be sine alpha. And what happens to this, right? We're going to use the half angle or double angle, whatever you want to call it, formula. Cosine alpha can actually be replaced with 1 minus 2 sine squared alpha over 2. And the reason why I use this version is because I want the 1 to cancel out. So that gives me 1 minus 1, 0, plus 2 times the sine squared. And again, if you square root it, we're going to use this information. We're going to get square root of 2 times sine alpha over 2. That's what we have on the left-hand side after putting the 1 on the right-hand side. And on the right-hand side, this is basically going to be cosine of 2 alpha, which is double angle formula, the other version. And this is sine of 2 alpha, which is nice. But guess what? I want to switch these around because I always like to write the sine first for some reason, probably OCD. Anyways, this is our equation. So far, so good, right? But we can make it better. How? By doing another hocus pocus manipulation or mathemagic, I guess. Here's what we're going to do. When you have sine plus cosine of the same angle, of course, then you can do a little nice manipulation. So our goal is to turn this sum into a product, or I should say sine or cosine of a single argument, which is going to be super duper helpful. So here's what we're going to do. We're going to take the sine of 2 alpha and multiply it by tangent pi over 4, which is actually 1. But can I just write it as sine of pi over 4 over cosine of pi over 4? Because that will be equivalent to tangent pi over 4, right? And that will be 1, so it's okay to multiply by 1, I guess, right? And then we're going to set it equal to the left-hand side, of course. But then we want to make a common denominator on the right-hand side. And that's going to give us something nice. So go ahead and actually, you know what? I probably want to put it here because I wanted to use the, never mind. I just realized it's better if I multiply the other guy by 1. And again, this is not going to hurt because I still have the same thing, okay? Sine 2 alpha. And then what I'm going to do is make a common denominator. And that's going to give me sine of 2 alpha times cosine of pi over 4 plus sine of pi over 4 times cosine of 2 alpha. Again, you just find out the better one by trial and error. That's what I did here. And now the numerator of the fraction on the right-hand side is actually the sine of a sum. Notice the pattern: sine 2 alpha, cosine beta, sine beta, cosine 2 alpha. You get the idea? In other words, the numerator is equal to sine of 2 alpha plus pi over 4. I like the sine formulas because plus is plus. Okay, that makes sense? I hope it does. Cosine pi over 4 is root 2 over 2. I guess you could also write it as 1 over root 2. So that way when you flip, it's going to turn into a root 2 as a factor, right? And notice that these two are going to cancel out because they're reciprocals. You get the idea? After you cross multiply. Cool. Now we got something super nice. Sine alpha over 2 equals sine of 2 alpha plus pi over 4. Awesome. Now we have sines on both sides, which is nice. And from here, we can basically branch off and come up with two solutions. We can say, hey, alpha over 2 is equal to 2 alpha plus pi over 4 plus 2 pi ni, or 2 n pi I, whatever. Basically, we're adding multiples of 2 pi because that's the period. Oops, there should be no I, by the way. I forgot. I was thinking about the other channel, which is a plus bi. So let me just insert a real quick commercial here. Ad break. Okay, you get the idea. And you know what? I could probably just switch these around because I like to keep bigger coefficients on the right. So maybe write it as 2 pi, 2 alpha plus pi over 4 equals this, alpha over 2 plus 2 pi n, or 2 n pi, whatever. N is an integer, by the way. And you can kind of put the alphas together. 2 alpha minus alpha over 2 equals negative pi over 4 plus 2 pi n. Obviously, before you simplify this, you want to turn this into a positive, which you can do by adding another 2 pi, because this contains multiples of 2 pi anyways, and you can go from there. Let me just quickly show you the second branch, and then I'm just gonna give you the solutions, because I don't want to keep this video too long and people stop watching, right? Okay, anyways, so that's the other solution. And guess what? After all this work, alpha, and because it has to be between 0 and pi, alpha is going to turn out to be 3 pi over 10. That's the only solution that satisfies. And x is cosine alpha, therefore cosine 3 pi over 10, which you can also write as cosine of 54 degrees. And cosine of 54 degrees is basically the square root of 10 minus 2 root 5 over 4, and that will be the answer. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.